cuma menjelaskan bahawa he is very interested in spatial data integrity and geomatics operation support. Dan tajuk presentation beliau pada hari ini ialah GIS application in Petronas and roles of geomatics. Dipersilakan Cik Zairi. Terima kasih.
Bismillahirrahmanirrahim. Thanks to Madam Chairman for a bit of introduction. And thanks to organizing committee for having me here today to present my presentation with the title of Roles of Geomatics in GIS. Is a bit changed from what you can see from the book. Frankly speaking, I have read some of the biography of the other presenter in this book, and they have a lot of experience. They have about 20 years of experience, and compared to me, I have about 7 years experience, and because of that, I feel very small, even though I'm in big size. So I try to present my presentation the best as I could. Okay, this is my content for my presentation today. I have about 6 agendas. We start with the introduction and followed by the EMP activity cycle and the complexity of EMP data. EMP here is the exploration and also the production, and the significance of geospatial data integrity, and I will go through in detail with the GIS application in Petronas and also Petronas Carigali, and the new initiative done by the OGP. I've been given about 25 minutes to complete my presentation, and I have only about 23 slides, and I believe I can complete my presentation within the time period. Okay, as a start, let's go back to the basics. What is the GIS? And I remember during my school days, my lecturer told me that GIS is Geographical Information System, but nowadays the definition, there is a new definition. For example, some others say that GIS is geoinformation. Some others say that GIS is a geospatial information system, but as long as it gives the same result or the objective is still the same, I think it's okay. But I don't want to discuss what is the GIS definition here. What I want to talk is actually, for example, like one organization or one company, if they decide to establish their own GIS department, the thing or the method that they discuss is more on the technology, which is the software and also the hardware. You can see here, we have a lot of software available in the market. You can choose whether you want to go to the very high end or you want to go to the low end. And also you can choose whether you want to have very complicated hardware. You can have the normal PC, the workstation, the high-end workstation, and also you can have tablet PC. But how you want to choose this technology is actually it depends on the application that that the company want to perform. For example, like in EMP, we list down all our application that we think that we can perform using the GIS, and then from that we choose our technology based on our application. But the most people forgot about setting up the GIS department is the data integrity, about the spatial element. And this is a very important matter in our EMP. But why? Why is data integrity is very important? Let me give you some example. The differences between EMP industry compared to the other industry. Most of our data is in offshore, and by working in offshore, you cannot simply put the marker in the offshore. You cannot simply put the X to be your marker or to locate your location. And somebody told me that you still can put a buoy, but you cannot 100% guarantee that the buoy will never move. And if it is moved, so it's hard for you to locate it back because you don't have any reference nearby. Okay, let's look into our EMP activity cycle. You can see here that we have about 6 stages. starting from acquiring right. This is where we bid our block and we do some regional geologies. And the second stage, we do the exploration stage, which is we do our seismic activity. We drill a couple of exploration wells. And the next one is appraisal stage. This is where we do the interpretation, and also we drill a couple of appraisal well. And if we think that the block is commercial, I mean, is good enough to produce, so we can develop our block, which is in the development stage. This is where we construct our platform, we lay our pipeline, and the next stage is the production stage. This is where the money comes in, and also the abandonment. So, but if you see carefully at each of these cycle, you can see there is a common thing that appeared every of this cycle, which is the maps and also the database. So, which means I can say here that the petroleum industry is location dependent, and 80% of our data is in offshore. So the data integrity is very important, and we are very concerned about it. Okay, let's look into the complexity of our data. Actually, we are involved in the very top until the very bottom. We navigate our vessel using the GNSS, and we also have a couple of platforms. Also, we locate them by using the GNSS. We construct our platform by using the barge, and we locate our anchor at the safe location. And if you see in the slide, we have a lot of structure on the seabed. We have a pipeline, we have the wellhead. And also we drill our prospect into the safest location. And down under the seabed, we have a lot of information. For example, we have the gas chimney, we have the seal, we have the sand, we have a reservoir, we have a trap. And this is where our hydrocarbon is coming from. Okay, for your information, we have a lot of data, and we try to class them into the different classes and based on the behavior. But the good thing about the data, all of this data have the G component, which is the geographical component. And without the G component, I can say that this data is considered useless, maybe. Okay, let's look into the journey of GIS in Petronas and also Petronas Carigali. I must admit here that we are a bit late to have the GIS in our company. But sometimes I'm thinking back that to be a latecomer is a blessing to us, because we have other partner or other company like Shell already have the GIS technology in their company long back years ago. So we can replicate, or we can study their journey, and we can choose the best solution. And if you see, we start our strategy in 1999, and then in 2005, we have our Petronas Corporate EP GIS. And in 2011, we start the second stage of Petronas Corporate EP GIS. And then in 2004, we start buying our own software. We start the Geomatics support in 2006, and also we start the PCSB GIS strategy. Okay, this is the architecture of GIS in Petronas and also Petronas Carigali. We have about 6 stages. Start with the end user. We have 3 main user, which is the data administrator, and our power user, which is using the IGS desktop for their own analysis. And we have a casual user that use the web base. And our database is in Oracle, and we also compile our raster database. And we have the corporate EP and project data. This is the interpreted data done by our geoscientists. And we are able to bring those interpreted data into our web base by using the OpenSpirit software as our integration. Okay, this is the interface of our PRI GIS. if we go to the Malaysia operation, you can see the block information. If you can, you also can see the international international boundary. And if you zoom more, you start to see the outline of the field, whether it's an oil field, whether it's a gas field, and also you can see our pipeline, our cables. And if we zoom more, you can start to see the platform outline. You can see the name of the platform. You also can see the name of the pipeline or the cable, the size of the cables or the size of the pipeline. And if you want to have more information, you can see the attribute of those data or those platform. And if you think that those data is not enough, you can download the report for that specific data. Okay, this is the current setup for our PIRI GIS. For your information, our PIRI GIS belongs to PMU. And this is the proposed PCSB Enterprise GIS, and this belong to PCSB. Some others said that why in Petronas we have two systems, which is the PIRI and also the proposed PCSB Enterprise GIS. For your information, PMU or Petronas is the mother company, and PCSB is a subsidiary of Petronas. So we are like this different company too, and also we are the contractor for PMU. And actually we are the same level as the other PSC like Shell, like ExxonMobil. So and then the main difference about these two systems, actually the PIRI GIS handle the domestic data, but for PCSB we handle the international data. Okay, let's forget about the architecture. Let's go through the application that some of the application that I bring in this presentation. I will go briefly on each of the application. Okay, as you see here, this is the GIS application for block acreage. This is where our PMU will try to design their block area aligned with their field outline. They also took into consideration the international boundary so that we can confirm that our block will not go beyond the international boundary. Okay, this is the GIS application for marine seismic. In this application, most of our geoscientists will try to use this application and try to calculate their survey coverage. And they will use this application to monitor their operation by using the pre-plot data versus the post-plot data so that they can make sure that the contractor do their job based on the contract requirement. The data involved in this application, for example, like pipeline data, the block coverage, the survey area, the pre-plot data, the wells, and also we need to know where is the nearest activity to our operation, because we doesn't want to have any obstruction or any, we call it as noise from the other activity. Okay, this is the GIS application for land seismic. I mean, it looks like the same like what we have in the marine seismic, but actually it's a totally different application. And this application for land seismic, our geoscientists try to design their pipeline and try to avoid any obstacle. For example, like the vegetation area, like the urban area, like the national park. But sometimes we cannot run away working at the people's lands. Sometimes we need to cut some trees. But together with the geoscientists, we use this application to calculate or to estimate how much compensation that we need to pay to the landowner. For example, we have recent project in Myanmar. We have been awarded the block by the Myanmar government, and Myanmar government want us to survey the seismic over there. And after we do some site reconnaissance survey, we found out that there is a lot of temple. There is about 200 temple in our block area. So I believe we need to plan our seismic area very carefully, and it gives us very hard time. Okay, this is the GIS application for development project. This is where we use a lot of raster image. We use the bathymetry chart, we use a mul chart, sometimes we use the satellite images, and sometimes we also have some LiDAR data to the specific area. Okay, this is the GIS application for geohazard risk analysis. This is where our geoscientists try to find their hazards so that they can avoid them later during the drilling campaign. The data involved in this application are coming from the side scan sonar, the sub-bottom profiler, and also the echo sounder. Okay, GIS application for anchor pattern. I can say that this application is very, very crucial and very, very important because we want to make sure that our anchor location are at the safest location. I mean, away from any obstacle, away from the pipeline, away from the cable. For example, if we are not plan this project carefully, we might drag the cable, or we might disturb the cable or the pipeline, and we doesn't want that to happen. Okay, for the new initiative, for your information, Petronas Carigali is a member of OGP. OGP is the oil and gas producer. We and the other member of OGP like Shell, like Chevron, like Woodside, like BP. And the purpose of having OGP actually is to find a project which give the benefit to all of us. And one of the initiatives done by OGP is a seabed survey data model. We call it as SSDM. SSDM initiated by Shell and Woodside in 2006, and proposed. I mean the reason that we have the SSDM is to provide the standard for the offshore seabed survey data deliverable from our survey contractor. And the purpose of having this SSDM is to define a GIS data model for seabed survey data interpretation in geodatabase to satisfy GIS query, and also the presentation and the data exchange. Okay, before we have this SSDM, we're having a difficulty with the existing data delivery. Most of our contractors submit their data in ACAD format, so it's giving us hard time to update into our database. And it also increased the data management effort for both client and also contractor. And it's also make it difficult to integrate our data because, I mean, in ACAD format, different contractor, they have their own data model or their own naming convention or everything. And it's also difficult to share data between joint venture partner. Okay, what are the benefits of SSDM? I mean, the good thing about the SSDM, we can store and serve from the corporate spatial database, and it's easy to integrate in subsurface workflow. Previously, we have a 2D map submitted by our contractor, and by having the SSDM, we are able to show them in 3D view. And then the good thing about this SSDM is to our interpreter. Previously, it's hard for them to integrate the site survey data into the interpretation. But if we have the SSDM, it's very easy. They can pull those data into the interpretation environment without a lot of data conversion, so that they can use those data for the interpretation in their interpretation software. Normally they use a Petrel, which is coming from Schlumberger. Okay, this is the SSDM 3D view by using the Fladerman software. This is the popular software for viewing the site survey data. And where are we now? And where are we heading? In 2009, we received a presentation on SSDM by Shell Berhad. And in 2010, we have the opportunity to send our staff to the Shell office so that they have opportunity and experience the implementation of SSDM. And after they coming back from the training, we have some internal discussion with regard to the implementation. And also we joined as a technical committee for SSDM. And we continued with to encourage our contractor to submit their data in GIS format. It's not yet in SSDM format, but it's in GIS format, so that they can have they can familiar with the GIS format, and later on it's easier for them to change to SSDM. But when we encourage them, I can see that they are not really want to change their way to submit their data, so we push them. In 2011, we add the SSDM requirement as an essential criteria in our scope of work for the new contract. And in 2012, we include the SSDM into our corporate GIS data model. And we are planning to convert all our data, the old data into SSDM format. And I believe this is a very difficult project. And hopefully that we can have the old data in SSDM in SSDM format. And this is my last slide. I believe, thank you very much.
Okay. Terima kasih ya, Cik Umar.